Year 12 and welcome to Purple Mountain Maths. We're doing the 2024 HSC paper for Maths Advanced. This is part 4, questions 16 and 17 worth 9 marks. Question 16. Flowers were planted in 2 gardens, Garden A and Garden B. On a particular day, 25 flowers were randomly selected from each garden and their heights measured in millimetres. The data are represented in parallel box plots. Compare the 2 data sets by examining the skewness of the distributions and the measures of central tendency and spread. Pause here to try yourself. Okay, so notice that there's 3 marks, so we need to provide a mark related to skewness as well as the measures of central tendency and spread. It's also important to note that it's not enough to just use words like higher and lower. We do need to support our opinions with numbers. So let's talk first about the numbers for each of these. So what I can see with Garden A, its median, I'm going to say that that is 171. Don't agonise over it if it's hard to read, but just give it your best shot. The IQR, I'm going to say that that's 176. I'm going to say that this is 159. So IQR equals 176 less 159 equals 17. And the range, I'm going to say that this is 184 and the min is, say, 145. So 184 less 145 equals 39. Let me get my numbers for Garden B as well. I'm going to say that its median is 152 and its IQR is going to be 158 less 149. So that is 9. And I'm going to say that its range is 172 less 144, so its range is 28. All right, let me answer the question in the order they gave it to me in. They first asked me about skewness, so I can see the shape of A is negatively skewed, and I can see that the shape of B is positively skewed. So let me say that first of all. A is negatively skewed while B is positively skewed. So that's enough for that first mark about skewness. Now I'm going to talk about central tendency, and I'm going to refer to the medians, and I'm going to use the numbers. A has a larger median of 171 compared to B at 152. So that's my comment on central tendency. Now let me talk about spread. I can talk about both IQR and range. I'm going to refer to both of them for completeness, but I could just refer to IQR. A has a larger IQR of 17 than B's IQR of 9. A has a larger range of 39 than B's range of 28. And I could also say something about the fact that 75% of A's flowers are higher than 75% of B's flowers. So I might just say that 75% of A's flowers are higher than 75% of B's flowers. Like I said, the minimums are similar in both gardens. And that's enough. Question 17. In a particular electrical circuit, the voltage V measured in volts across a capacitor is given by V of t equals 6.5 outside of 1 minus e to the minus kt, where k is a positive constant and t is the number of seconds after the circuit is switched on. Part A. Draw a sketch of the graph of V of t showing its behaviour as t increases. Pause here to try it yourself. All right, let's do this. Okay, so let's look at the structure of this question. So V of t equals 6.5 minus 6.5 e to the minus kt. So we know what an exponential looks like. Y equals e to the x looks like this. We know what it looks like if the x is negative. So then it's this shape. We know what it would look like by introducing the minus into it. So it would be flipped down, and then we know what would happen if we added a constant to that. So we would be approaching that constant, and it would look like this. So that's the shape that we're going for. This is a lovely question. If you're at all interested in electrical engineering, then this question is really for you. So this is what the voltage through a capacitor looks like. At t equals 0, V is 0, so it goes through 0, 0, and it approaches that value of 6.5 volts as time increases. So let's label that V of t equals 6.5 outside of 1 minus e to the minus kt. And that's it for part A. Okay, in part B, we're told that when t equals 1, the voltage across the capacitor is 2.6 volts, and we're supposed to use that information to find the value of k, correct to 3 decimal places. So we already have a function, v is a function of t, equals 6.5 minus 6.5 e to the minus kt, and we know that if t equals 1, v of 1 equals 6.5 minus 6.5 e to the minus k times 1, and that equals 2.6. So 6.5 e to the minus k must be the difference between 6.5 and 2.6, which is, what's that, must be 3.9. So e to the minus k equals 3.9 on 6.5. Let's take the natural log of both sides. So we can get minus k equals ln of 3.5 on 3.9 on 6.5. So k equals minus ln 3.9 on 6.5. We can use our calculator to figure what that is. Minus 1 times ln of 3.9 over 6.5. And we get k equals 0.5108. 08, but they want 3 decimal places, so I'm just going to hold it there as 0.511. And that's my answer for part B. All right, part C says find the rate at which the voltage is increasing when t equals 2, correct to 3 decimal places. So please notice that word rate. You know from your Year 8 rates and ratios work that rates have units, so we must remember to put in the units. So if V is a function of t equals 6.5 minus 6.5 e to the minus 0.511t, then dv dt is the first derivative of that, which is minus 6.5 times 0.511 e to the minus 0.511t. At t equals 2, I'm going to get 6.5 times 0.511 times e to the minus 0.511 times 2. I put all of that in my calculator and I get 1.195, and that is in units of volts per second. Okay, that's the end of part 4. Thanks for listening to Purple Mountain Maths.